Questions 21 through 25 on the 2017 Grade 8 AMC 8. Suppose A, B, C are non-zero real numbers and A plus B plus C is equal to 0. What are the possible values for A over A absolute value plus B over B absolute value plus C over the absolute value of C plus A times B times C over the absolute value of A times B times C? This is one of those plug-and-play questions. You just got to plug in some numbers and see what you get. So let's just start off with a simple one. Let's say A is 1, B is 1, and C is minus 2. That would indeed give me 0. Okay, now let's figure out what's the value for that. That's going to be 1 over absolute value of 1 plus 1 over the absolute value of 1 plus negative 2 over the absolute value of negative 2 plus 1 times negative 2 times, over I should say, the absolute value of 1 times negative 2. So that gives me the following: 1 plus 1 minus 1 minus 1, and that is 0. And the good news is that this is the only possible value. If you plug in any other values, integers, that make that true, so whatever, negative 3, 1, and 2, and then you did this calculation for those numbers, you'll find again it gives you 0 as an answer. So number 21, the answer is A. In the right triangle ABC, AC is 12, BC is 5, and C is a right angle. Semicircle is inscribed in the triangle. What is the radius of the semicircle? Well, let's draw the radius from there to there. That's the tangent point. This is also the radius. And let's start labeling. So I'll call that R. I'll call this R. This is, of course, right angle. And that tangent point is also going to be a right angle. So now this is 5, and therefore the distance from there to there will also be 5, since if you start at a point and then you hit the circle at two tangent points, those distances will be the same. And then from Pythagoras, you can easily figure out that 12 squared plus 5 squared is equal to AB squared, and that AB is therefore equal to 13. So this whole distance is 13, and this distance is 5, so that means this distance is 13 minus 5, which is 8. And then this whole distance is 12. This distance is R. So the distance from there to there is 12 minus R. So put 12 minus R. All right, so now this gives me another Pythagorean relationship, that triangle. 8 squared plus R squared is equal to 12 minus R squared. So 64 plus R squared is equal to 144 minus 24R plus R squared. And therefore I got 24R is equal to 80. And therefore R is equal to 80 over 24, which is 10 over 3. So number 22, the answer is D. Each day for 4 days, Linda traveled for 1 hour at a speed that resulted in her traveling 1 mile in an integer number of minutes. Each day after the first, her speed decreased so that the number of minutes to travel 1 mile increased by 5 minutes over the preceding day. Each of the 4 days, her distance traveled was also an integer number of miles. What was the total number of miles for the 4 trips? Well, speed is equal to distance over time, and if we made a little list here, miles per hour, and the amount of minutes it takes to travel 1 mile, well, we will only get integer values. For example, for 60, it would be one minute to travel 1 mile. And similarly, integer values will only happen for factors of 60. So 30, 20, 15, 12, 10, 6, 5, 4, 3, 2, 1. And the corresponding values will be 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. So they're saying that she is traveling in a way so that every time the number of minutes to travel 1 mile increased by 5 minutes. Okay, so I think she initially took 5 minutes, like that, and then increased by 5 minutes, so 10 minutes, and then 15 minutes, and then 20 minutes. That's the only way to do it. So that means her speeds were 12, 6, 4, and 3 miles per hour. So what was the total number of miles? Okay, well, total number of miles, we can use the distance is equal to speed times time. Each time, the time is 1 hour. So distance is going to be speed times 1, which is just s. So the distance for the first one, when the speed is 12 miles per hour, is just 12. The next day, the distance is 6. The next day, the distance is 4. And the fourth day, the distance is 3. So then they want the total. So that looks like 25. Number 23, the answer, therefore, is C. Mrs. Sanders has 3 grandchildren who call her regularly. One calls her every 3 days, one calls her every 4 days, and one calls her every 5 days. All 3 called her on December 21st, 2016. On how many days during the next year did she not receive a phone call from any of her grandchildren? What I recommend to you is start off with a small example and then learn this system, and then you can extrapolate it to a big example, which is what we have, involving 365 days. So we have the one who calls her every 3rd day. So 3rd day, 6th day, 9th day, ... So the number of days would be 365 divided by 3, and you take the integer value. Then you have the other grandchild who calls her every 4th day. So the number of days that he calls or she calls is 365 divided by 4, the integer value. And then the one who calls her every 5th day will be 5, 10, 15, and so on. Those days are 365 divided by 5, the integer value. So the total is 365 days minus 365 divided by 3, the integer value, 365 divided by 4, that integer value, minus 365 divided by 5. But it's not that simple, because we have over subtracted. Because, for example, let's say this was 12, the next one. Notice 12 appears in both lists. So if we subtracted 12 here, we then again subtracted 12 there. So because we over subtracted, we have to add back some. We have to add back multiples of 3 and 4, which would be 12. We also have to add back multiples of 4 and 5, which is 20. And we also have to add back multiples of 3 and 5, which is 15. 365 over 15. And it's not that simple. There's one other thing we have to do, and I think that's the one that might be the hardest, is that we also have to take into consideration numbers that are the multiples of 3, 4, and 5, which would be multiples of 60. So 365 divided by 60. And those we have already subtracted. We subtracted 60 here, here, here. We added 60 back here, added it back here, added it back here. So we basically subtracted it 3 times, added it 3 times. So we have to now actually subtract it at least once. And therefore, we do subtract it at least once by putting a negative sign here. So that's how you do this. So these numbers are going to be 365 minus 121 minus 91 minus 73 plus 30 plus 18 plus 24 minus 6. And when you do that whole math, you get 146. And therefore, number 24, the answer is D. In the figure shown, line US and line UT are line segments, each of length 2, and the measure of angle TUS is 60. Arcs TR and SR are each 1/6 of a circle with radius 2. What is the area of the region shown? Here is that diagram. Let's cut it up a little bit. Draw a line there, draw a line here, and we've got to make a circle here. And let's try to make this diagram in a way so that it's not confusing in the least. So let's draw the center to that shape, and then a couple more lines. One line that goes down straight like that, and then one more line that goes like that. And I think that should be sufficient. May not be perfectly drawn to scale, but that's okay. Now, we of course have to figure out the area of this shape right here. So first what I'll do is I'll just concentrate on the top part, that triangle, and then we'll concentrate on the bottom. All right, so the top part, they told me this is 2, and that this is 60 degrees. Therefore, since that line chops that angle in half, this is going to be 30 degrees. And this is 90 since that was a perpendicular, and therefore this is 60. And using your 30, 60, 90 triangles, we can easily figure out the height of this triangle. H over 2 will be the equivalent of root 3 over 2. Because the sides of a 30, 60, 90 triangle have the ratio 2, 1, and root 3. And therefore, this basically gives me that H is root 3. Okay, so that means that top part, that top triangle, has area of 1/2 base. Well, the base is going to be 2, since this is 1, and that's basically an equilateral triangle, since that's 60 also. And the height we just figured out was root 3. So the top we quickly figured out is root 3. Now I've got to figure out the area of this guy right here, this bottom segment. What I'm going to do is just concentrate on half of it, and then at the end I'll just double it. So that part's done. Now the next part, we first will figure out the area of this triangle right here. And that triangle, I'll just call it bottom triangle. And that's going to be, again, 1/2 base times height. Same thing, we need to figure out this H from here to here. And in the same way, H over 1 is the same as root 3 over 1, and therefore H is root 3. Because that's also a 30, 60, 90 triangle. Since this is 90, and this here, we can figure out, because they told me that this is 1/6 of the circumference of the circle, so that means this is 60. 60 over 360 is 1/6. And this is the radius, so they told me it's 2, that's 2. And that means that's isosceles, so this angle must be the same as that angle. So those two angles add up to 120, so each of those is 60. So if that's 60, then this is 30. So therefore this angle is 60, and again we've got a 30, 60, 90 triangle. So that's how I was able to get this right here. So the bottom triangle, which is this guy right here, that one has 1/2 base times height as the area. The base is 1, the height is root 3. So that's root 3 over 2. But I'm not interested in that, really. I'm interested sort of in this shape right here. And that shape is the equivalent of the bottom triangle minus that cap. And that cap, I'll just put right here, cap. That cap is basically this segment right here that sits sort of in the middle. Okay, Well, let's figure out the area of the cap. The area of the cap we can figure out basically by first figuring out the area of this pi segment and then subtracting from it that triangle. So the cap is the pi segment minus the triangle. Well, the pi is 1/6 the area of the circle, pi r squared, and r is 2. And this triangle is basically an equilateral triangle with side length 2. And just as we did before, you can just drop a perpendicular and figure out the height right here. So it would be 1/2 base, which is 2 since it's equilateral, and height you can easily get from the 30-60-90 relationship like we did twice already, and that was going to be √3 for the height. So this is going to be 4 pi over 6, so 2 pi over 3 minus √3. So now we can figure out the bottom triangle minus the cap. The bottom triangle minus the cap is going to be √3 over 2 minus 2 pi over 3 plus √3. And that looks like 3 √3 over 2 minus 2 pi over 3. All right, so we are almost done here. Now we just figured out this part, but we're going to double it because we have to figure out that part also, right? And that's just twice of what we figured out right here. So 2 times that would be 3 √3 minus 4 pi over 3. So that's this part right here. And then don't forget to add it to the top part, which I had figured out right here. So when we add it to the top part, add that √3 from up here. And when you do, you get 4 √3 minus 4 pi over 3. 4 √3 minus 4 pi over 3 is choice B for number 25.